Welcome viewers. In this video we'll see the phasor diagram of a loaded alternator for lagging power factor load. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, phasor diagram of a loaded alternator for lagging power factor. In case of inductive load, we'll get the lagging power factor. So in this phasor diagram, this V phase is taken as a reference. Now we'll see the equivalent circuit and voltage equation so that we are able to understand easily this phasor diagram. First we will see the equivalent circuit. So this is the equivalent circuit of the alternator. This E phase is the induced EMF per phase, EMF induced in the alternator. V phase is the voltage available at the load terminal. So in between we have reactance drop and resistance drop, that is RA, armature resistance drop. XAR is nothing but armature reaction reactance. XL is the armature leakage reactance, right? So we can add these two so that it will be simplified as this is the another diagram. So this XL and XAR is added, so it becomes XS, synchronous reactance. Then XS and RA and XS is added, that become a synchronous impedance. So the generated EMF plus drop is this generated EMF equal to voltage drop plus voltage available at the load. So that is the equivalence, is a simplified equation. So E phase equal to V phase plus drop. Now we'll see the voltage equation so that we are able to understand the phasor diagram easily. So the voltage equation, the EMF generated in an alternator E phase is not completely available at the load due to the drop across RA, armature resistance, then XS, armature synchronous impedance. So that is given here. E phase equal to V phase, generated EMF equal to voltage available across the load, then resistive drop and reactance drop. So these two, this RA and XS can be written as a synchronous impedance. So E phase equal to V phase plus IA ZS. So this is the final equation. So in the phasor diagram we have to obtain this relation. This E phase is the vector sum of V phase plus drop, reactance, that is the impedance drop, IA ZS. So based on this, now we'll see the phasor diagram. So the phasor diagram for lagging power factor, we are taking V phase as a reference. Now we'll refer the diagram. So this is the E phase, our final value, voltage induced in the armature. So that is the vector sum of V phase and IA ZS. Impedance drop, synchronous impedance drop. So just now we see that V phase is the vector, E phase is the vector sum of V phase and IA ZS. What is IA ZS? This impedance is nothing but resistance and reactance. Armature resistance drop, IARA, then synchronous reactance drop, IAXS. So vector sum of these two is nothing but IAZS, right? Then this is the V phase taken as a reference. This is the current, is lagging. Current is lagging by pi. This V phase is split into two components, horizontal and vertical. V phase cos pi. This OE is nothing but V phase cos pi. A is nothing but V phase sin pi. Sum of these two is the V phase. So this triangle is extended. Finally we have O, C and D. Right? Final diagram is available. Now finally we have to prove that E phase is the vector sum of V phase and IA ZS. Right. Now we'll see this one by one. As inductive load is connected the current IA lags the applied voltage V phase by an angle pi. So that I have already discussed. This current is lagging. So in this diagram, this IA RA drop is in phase with the current. See, this both are in phase. This IA excess is 90-degree phase shift with the IA. Resistive drop is in phase. Reactance drop is 90-degree with the current IA. Our aim is to find the value of OC, that is E phase. E phase is OC. V phase is OA. Impedance, synchronous impedance drop is AC. Vp cos pi is OE. Vp sin pi is AE. So based on that, we will refer the description one by one. Then finally we will get the expression for the E phase. So this description is given what we discussed. An inductive load is connected by the current IA lags the voltage V phase by an angle pi. The IA RA drop is in phase with the IA that we discussed in the diagram. So it is represented by AB equal to IA. Then IA excess drop, that is at an angle of 90 degree with IA RA. So BC equal to IA excess. AB is IA RA, BC is IA excess. Then sum of these two is the IA ZS, impedance, synchronous impedance drop. Is the vector sum of IA RA and IA excess, that is represented by AC. So finally this E phase equal to V phase plus IA ZS. So this E phase is given by OC. Now we'll see the remaining. So from a right angled triangle ODC, by extending the points B and O, we know that OA equal to V phase. Just now we discussed. V phase cos pi is OE. V phase sin pi is AE and also BD. Both are same. IA RA is AB, that is equal to ED also. So this is the notation given. So from the triangle OC square equal to OD square plus DC square. So this OD can be written as OE plus ED square splitted. DC is written as DB plus BC square. Now I will refer the diagram so that it will be easier. So this OC square equal to OD square plus DC square. This OD is written as OE plus ED. This DC is written as DB plus BC. So OE is nothing but V phase cos pi. ED is nothing but IARA. Both are same. This value is nothing but IARA. This BD is nothing but V phase sin pi. This value. Both are same. This BC is nothing but IA excess. So based on that, now we can go to the equation. So that is written here. OD is written as OE plus ED square. DC is written as DB plus BC square. Now substitute the value. OE is nothing but V phase cos pi. ED is IARA square. DB is V phase sin pi. BC is IA excess square. Now we'll take the square root on both the sides. So OC equal to square root of V phase cos pi plus IARA the whole square plus V phase sin pi plus IA excess the whole square. So this OC is nothing but, what is the value of OC is nothing but E phase. This OC is the E phase. So E phase is the this value. So finally we got the value of E phase. So in this video we discussed the Phasor diagram of loaded alternator lagging power factor while connecting inductive load. First we discuss the equivalent circuit followed by voltage equation. Voltage equation is voltage induced in the armature equal to voltage available at the load terminal plus drop. That is our final aim to, we have to prove that. Then in the phasor diagram we discuss all the parameters. Finally we got this value. This E phase is the vector sum of V phase and drop. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.